I'm Anil Kumar, and as usual, I'm sharing a test paper of my student with you. This one is on rate of change advanced functions grade 12. Now the student did score 90%. Here is the mistake which she committed. Now I shouldn't really call it a mistake. It has been almost a year since you read about trigonometry, so you're kind of out of touch. The question here is, let me show you the question and then discuss it. A crystal in the shape of an equilateral triangular prism is growing in a test tube. Estimate the rate at which the surface area is changing with respect to the side length of the crystal. So that is the question. It is indeed a very difficult question for unit test 2 since trigonometry is yet to come. Now let us first find out what is the formula for surface area of a equilateral triangular prism, and that was probably the major part. So triangular prism is kind of like this. When we say equilateral, that means we can make an equilateral triangle and then complete the prism part. Let me use a different ink so that later I can actually draw and show you the surface area also. So we'll kind of make this a triangular prism here, so we'll have another triangle here. This is the back side of this, so let us say that is the triangular prism for us. Now we need to find the surface area of this triangular prism, which is fortunately an equilateral triangular prism. Now equilateral means that all sides are equal, and if I draw a perpendicular, it is going to bisect this segment. It is right angles, and from this we can actually find all the sides. Since we have equilateral triangular prism, let us assume that the sides are x. So all these sides for us are x, correct? Now surface area is, we have two triangles here. So surface area of two triangles, let's develop a formula for this. So surface area is, we have two triangles. What we will do is, we'll actually draw these triangles and let's open this up. So we have two triangles, one on the top like that, that's an equilateral triangle, and then we have that is one side which flips, right? And then we have this other triangle at the back. I'm not making it so accurate, but you get an idea. And these are our three rectangles, correct? So that is the triangular prism, and in this triangular prism all sides are x. They may not look like, but they are indeed x, correct? Now so I can make so many x's now. Fine. What is the area of the triangle? The area of the triangle is half base into height. So the whole thing is to find the height, and I think that is where things go wrong. Base, we know it is x. Now this angle is 60 degrees. So we can use a lot of properties to find height. What is 60, 30, 90 triangle? Right? That shows you this height should be square root 3 over 2. The other way to find the height, let me write h here, and let me write height in this case is equal to sine of 60, right? Sine of 60 degrees, correct? Times hypotenuse. Since h over x, right? H over x, which is the hypotenuse, is equals to sine of 60 degrees. So height is equal to, so we can write height as equal to x times sine of 60 degrees, correct? And sine of 60 degrees is square root 3 over 2, right? Or you could also use a special triangle 30, 60, 90 and get sine 60. So from here what we found is that height is equals to square root 3 over 2 x, right? And that is how you get, because sine 60 is square root 3 over 2. Or you could use a 60, 30, 90 special triangle to get this height. Now we have two of such triangles. So area of the triangle is, we have two triangles. So we have two triangles. Let me write first two triangles plus three rectangles. Let me write like this. Okay, let's continue. 2 times area of the triangle is half base. It is half base, in this case is x, base times height h, which is square root 3 over 2x. So that is the area of these two triangles. We have multiplied by 2. Now we are left with these three rectangles. So their length and width is x. So we'll get 3x squared. So that is how we can get surface area of our equilateral triangular prism, right? We can simplify this. X times x is x squared, half and half cancels, okay? So we are left with x squared. Let me write it here. And if I take x squared and the numbers common, so we'll just keep these fractions as such. Okay, these are too complicated to touch, so we'll just keep them separate. So let me now separate my work area with the diagram. Okay, that is how it is. So the surface area is square root 3 over 2 plus 3. We took x squared common. That is the surface area. Now let's look at the question once again. A crystal in the shape of an equilateral triangular prism is growing in a test tube. Estimate the rate at which surface area is changing with respect to the side length of the crystal. So with respect to x, what is the rate at which the surface area is changing, right? So if we really want to find the rate of change, then what do? So for any moment, it is f of x plus h minus f of x over h, right? So in the test paper, it was to be calculated for x equals to 3. But what we are going to do here is find out a general expression, right? So that when you get it in your test, you get it right. So that is what it is. Now, the function is square root 3 over 2 plus 3 is x square. You know that is a constant that is not going to change. This is the changing area. So let's write down the expression f of x plus h minus f of x over h. Now that is to say we have all this, which is square root 3 over 2 plus 3 times x plus h. So that is the first factor, x plus h whole square minus f of x, which is how much? F of x will be this whole thing, right? It is square root 3 over t plus 3 x square, right? Divided by h. So everything divided by h. Where of course we know h is very, very small as compared to 1, since we are looking for instantaneous rate of change. Correct? So that is how it is. Now let me expand this. So I can take this factor as common. So let me write this as square root 3 over 2 plus 3, because I know I'm running out of space here. And within the bracket, what do I get? I get x plus h whole square minus x squared, correct? So I'll just expand this. So what I get is x squared plus 2xh plus h square, and then this x square, which comes here. Is it okay? Everything divided by h. Now in this expression, as you know, always in rate of change, that x square gets cancelled. And we also know that h square will be almost negligible, right? Since h is very, very small. So we can kind of, this approaches 0. Is that okay? We are left with 2xh, and so we can cancel x, h and h. So what do we get here? We get 2xh. So let me write down here the whole number here, which is square root 3 over 2 plus 3 times 2x. That is the rate of change, okay? So let me just separate this part which we discussed up here. So that is the rate of change at any instant. Do you understand? Now, since the question was based on at x equals to 3, let me add that part now. So we'll find the rate of change at x equals to 3 also, so that we really do the question which we intended to start with. But that's a very general expression which should help you to answer any question relating this, correct? Particularly at 3, it is how much? It is equal to square root 3. We can always write this as plus 6 over 2, right? Times 2 times 3, right? 2 times 3, which is 6, right? So it is 2 and 2 will cancel out, so we can write this as 3 times square root 3 plus 6, right? Now, can you tell me what are the units for this? So the dimensions of length, let it be unit, right? So it is unit. Area on the top means unit square divided by length will be unit, right? This is also very important in test paper. You could lose 0.5 marks for not writing the units, right? So rate of change at x equals to 3 will be, you substitute x as 3, right? And then you get cancel these 2's, right? And multiply by 3. So 3 square root 3 plus 18 is your exact answer. You can always use calculator around your answer to any number of places you need and write down. But the whole idea is understand how to find surface area. Once you find that, then it's so simple. It's just like finding instantaneous rate of change for a parabola, right? So that's how it is. I hope you understand the concept, and if you get it in your test, then you max your paper. Thank you and all the best.